Chapter 10: The Full Block Stacked. We have all the pieces. Now we assemble them into one transformer block, and then stack that block over and over into a deep model. A transformer block has just two main parts, and we've built both. Attention, where words share information. And the feed-forward network, where each word is processed on its own. But to make a deep stack of these actually trainable, we wrap each part with two more tricks: a residual connection and layer normalization. First, the residual connection. Instead of replacing the vector, each part adds its result back to the original. Output equals input plus what the layer computed. Why? Two reasons. The original information is never lost, it flows straight through. And during training, gradients get a clean highway all the way back. Without residuals, very deep networks simply refuse to learn. Second, layer normalization. Before each part, we clean up the vector. We rescale its numbers so they have a consistent mean and spread, not too big, not too small. This keeps the math stable as signals pass through dozens of layers. Think of it as recentering the values so no single number can blow up and derail the whole computation. Put it together and here is one complete block. The vector comes in. Normalize, run attention, add the result back. Normalize again, run the feed-forward network, add that back. Two sublayers, each wrapped in normalize, then add. The vector that leaves is the same size as the one that entered, so blocks chain together perfectly. And chain they do. A small model might stack 12 of these blocks. Larger ones use 24, 48, even nearly 100. Every block has its own fresh set of weights and refines the vectors a little more. Same shape in, same shape out, just stacked deeper and deeper. What does all that depth actually buy? A rough but useful picture. The early blocks handle surface patterns, grammar, word forms, who is next to whom. The middle blocks assemble phrases and relationships. And the deepest blocks capture abstract meaning and intent. Layer by layer, raw tokens grow into genuine understanding of the text. So let's trace the entire journey end to end. Text becomes tokens, tokens become embeddings, we add position. Then the stack of blocks, attention and feed forward again and again. The final vector becomes logits, Softmax makes probabilities. That is a complete forward pass of a language model, everything we have built in one pipeline. So the full stack. One block is attention plus feed forward, each wrapped in normalize and add. Stack that block many times and shallow patterns grow into deep meaning. We can now run text all the way to a next word probability. But how did the model ever learn the right weights? Next, training and loss.